11.5 Volumes of pyramids and cones. Pyramids and cones are going to be very similar to prisms and cylinders. Okay, so let's see where the differences are. Our first theorem here, volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. Okay, we recognize quite a bit of this formula here. We know that once again, B is the area of the base, so whatever shape that is. And we know that in pyramids, you have one polygon that is your base. It's opposite of the pointy part up here. And so we find the area of the base. And again, on pyramids, the height goes from your vertex perpendicular to the base. This is the height of the pyramid. This is H pyramid. That is important. Now, we're referencing Cavalari's principle again here. This formula is true for all pyramids, okay, even our oblique ones, because height still is measured from your vertex perpendicular to the plane that the base sits on. So this is just like our oblique cylinders and oblique prisms. All right, let's look at an example here. Finding the volume of a pyramid. If you've ever been to the Louvre, and I'm sure some of you have, or at least seen pictures of it, there is this pyramid, this glass pyramid, that sits in the front. And it is a square pyramid, which tells us that the base is a square. And we are told, square pyramid, told that it has a height of 21.64 meters. We want to know the volume of that. So how much air is in there? So to find the area, we find the area of the base. The area of the base is just the area of a square, right? And so we know that right here we are told this side is 35.4 meters. We multiply that by another 35.4 because it's a square. And then we take the area of the base and substitute it in. And we are told that our height, so that goes perpendicular to that, told that the height is 21.6. We simply put it into our formula, multiply it out, and get a volume of about 9,039, would be 0.5 to the nearest tenth, cubic meters. That's easy enough. Let's look at our next example, because you know they're never that easy. What is the volume of a square pyramid with base edges of 40 feet? Oh, and here's where they're trying to get us. A slant height of 25 feet. So we know we have a slant height. That's the height of our triangular face. And we know we have a 40-foot base edge. So what we're going to do, we need the height of the pyramid here for our equation. So we draw our triangle here, and we know we get a right triangle, and we see that we have two sides of that right triangle looking for the third. So that should scream Pythagorean theorem. We know that the hypotenuse is always C. Use our Pythagorean theorem. Substitute in. Don't forget, we square root both sides. Make sure you show that. And we get the height is 15 feet. Now we have everything we need. We can find the area of our base. It's just a square, so 40 times 40. And the height is 15. I recommend doing this part right here separately because sometimes they can be more of a challenge than a square. We simply substitute in and get our answer. All right, pause the video and try the examples. Okay, problem number 1 says a sports arena shaped like a pyramid has a base area and a height. So we are given big B, and we just put that into our formula. Don't forget the 1/3 because it is a pyramid. And we just put in our numbers and we get 32,100,000 cubic feet. That is a lot of air to be filling that sports arena. But they are large, so we would expect a large number. All right, number 2, what is the volume of a square pyramid with base edges and slant height is what we're given. So I sketched myself a little square pyramid here, and I know the base length of my square base is 24. The height of my square base is 24, so I can find the area of my base is just the area of a square. I get 516 meters squared, and I'm given slant height, but I want the height of the pyramid. Make sure you label those on your diagram so you know which one you're looking for. Again, we have a right triangle and 2 of the sides are given. That says Pythagorean theorem. Always remember that C is the hypotenuse. I plug in my numbers, do my math, do not forget to square root, and I get a height of 5. If you remember, a 12 and a 13 are part of a Pythagorean triple. This is a 5, 12, 13 Pythagorean triple. This one's a little harder to remember. Then we just write our volume formula, 1/3 times the area of the base times the height of the pyramid. Plug in our numbers, and the volume of our pyramid is 960 cubic meters. So these are not too bad. Don't forget the 1/3. All right, cones. These are just like all of our other circular figures. This is a circular pyramid, which has a special name of a cone. The area of the base is a circle, so we can just take our formula, and right here for the area of the base, we know the area of the base is just the area of a circle, which is pi r squared. We substitute that in, and the area of, or the volume of a cone is 1/3 the area of the base, which is a circle, times the height of the cone. Again, don't forget it's the height of the cone, not the slant height, is just 1/3 pi r squared h. This formula will work for all cones. So that's pretty awesome. Now, let's look at our example here. We have a teepee, and teepees are approximated by a cone. Our teepee is 12 feet high with a base diameter of 14 feet. We want the volume. The most difficult thing here is we are given diameter, which means we need to find radius, because with all circles, radius is what's going to be important. And then we write our formula. Don't forget that 1/3. 1/3 pi r squared h. We substitute in, and we could leave this in terms of pi, which would be 196 pi feet cubed, or 615.8 feet cubed, depending on whether we want it in terms of pi or to the nearest tenth. Okay, pause the video and do the next example. All right. We were told that the height and radius of the child's teepee are half of those in the problem above. So we know our height is 6 feet, our radius now is 3.5 feet. We substitute all of our numbers in and we get the volume of our cone is 24.5 pi feet cubed, or 76.969 would round to 77.0 feet cubed. And then we are said, what is the relationship between volume when you half the height and half the radius? Well, if we were just having the height, it would be 1/2, because height is being multiplied. So if we're just multiplying by 1/2, it would just cut it in half. But the radius is squared, and we have seen before what squaring the radius will do. That makes it 1/4 as much, right? Because 1/2 squared is 1/4. So both of these are going to have an effect. 1/2 times 1/4 is 1/8. It is going to be 1/8 as small if we have everything. So we can check this. 615.7 divided by 8 is 76.96, which is what we got. All right. We were told that this formula applies to all cones, and that includes oblique cones, just like our prisms. Volume applies to oblique prisms too, because when we tilt our stack of paper, we don't change the volume of it. So let's look at our next example here. If we're finding the volume of an oblique cone, we know that we need radius. So we're given diameter, so radius is 15, and we know the height of our cone because it goes from the vertex perpendicular to the base. So the height of our cone is 25. We put everything into our formula. Be careful, make sure that you are squaring that radius first, and that gives us 1,875 pi. This is feet cubed, and if necessary, we throw that into our calculator and get a decimal. So easy enough. All right, we're almost done. Pause the video and do the last two problems. Okay, the first one said the volume of the oblique cone to the right in terms of pi and to the nearest cubic meter. I did mine to the nearest tenth. All right, so volume of a cone is volume of a cone. We need the height of the cone, which is 12 meters, and the radius, which is 6 meters. We plug it into our formula. That's 144 pi meters cubed. And if we put that into our calculator, to the nearest cubic meter, that means a whole number would be 452 meters cubed. Standard is 1 or 2 decimal places, but we were told nearest cubic meter. All right, and that one was easy enough. The last one is, how does the volume of an oblique cone compare to the volume of a right cone with the same diameter and height? They are going to be the same, because volume is volume, whether our stack of papers is straight up and down or whether our stack of papers is tilted. This is because the area of the base is based on the diameter, based on the radius. We should maybe write radius there. Diameter gives us radius. So the area of the base is going to be the same, and the height is also going to be the same, because height is simply the vertex measured perpendicular to the base. So our vertex doesn't change, we just slide it over some, and it's always measured perpendicular to the base, so those are going to be the same. Well, this one went nice and quickly. Again, label everything. Label it clearly. Label the height of your pyramid or cone. Label the height and base of your base so that you can tell them apart. Write your formulas, substitute in, make sure you are squaring when necessary, make sure you are square rooting if you are using the Pythagorean theorem. and all should go quite well. These are some of the easiest ones we've done, so I believe you will do well.